You ran the same coding job through Kimi K3 and Claude Opus 5, and one bill came back 10 times higher than the other. That gap doesn't round off, and GPT 5.6 Sol sits right in the middle, wondering if it belongs here. These are three coding agents fighting for your API budget, and the real question is whether raw benchmark accuracy is worth paying a massive premium, because the answer changes your whole build decision. Test 1. Cost per token. You're running an agent loop that churns through 10 million output tokens a month, which is pretty normal for any production coding workflow. At that volume, the wrong model choice doesn't just sting a little, it wipes out your whole infrastructure budget. So let's look at what each of these actually charges you on output. I pulled official pricing pages for all three. Kimi K3 comes in at $0.60 per million odd input tokens, $2.50 on output. Claude Opus 5 is 5.0 input and 25.0 output. GPT 5.6 Sol lands at 1.25 input and 10.0 output. At 10 million output tokens a month, Kimi runs you $25, Claude runs you $250, same volume, same job. Kimi K3 takes cost, and it's not close, 10 times cheaper on output than Claude Opus 5 and twice as cheap as GPT 5.6 Sol, which puts Kimi K3 up 1-0. I expected the gap to be meaningful, but a full order of magnitude on output pricing is the kind of number that rewrites your whole build decision. I only caught that pricing gap because I've been living inside these tools long enough to check the fine print before committing to a stack. Drop a comment if a surprise API bill has ever wrecked your month. Test 2. Coding benchmark performance. You ship a PR on Friday, the model misses a subtle bug, and now you're explaining a production incident on Monday morning. SweBench verified is the closest thing we have to a real measure of that, because it uses actual GitHub issues, not toy problems. So the score here is the one that actually maps to your on-call risk. The part that got me is how cleanly Claude Opus 5 leads here. On SweBench verified, Claude Opus 5 scores 80.9, GPT 5.6 Sol is at 78.2, and Kimi K3 trails at 72.4. Terminal Bench follows the same order, Claude 71.3, GPT 5.6 Sol 68.7, Kimi 65.1. These are vendor-reported numbers, so treat them as directional, but the gap is consistent across both tests. One of the biggest problems I run into when using AI agents is turning their output into YouTube content I can actually use to market my product. That's why this video is sponsored by Subscriber, a tool that helps business owners connect their AI agents to YouTube and market their products without spending 10 hours every week creating content. You can connect Claude or ChatGPT directly to Subscriber. It then analyzes your business, website, and YouTube channel to help you create SEO-optimized video ideas, scripts, thumbnails, and even complete videos that actually match your brand. What I like most is that every week, Subscriber gives me a list of high-potential video ideas I can immediately execute, and it can even help edit videos for me, with or without my face, including videos like the one you're watching right now. It's easy to get started, and you can try Subscriber for free using the link in the description below. Now back to the video. Claude Opus 5 takes coding benchmarks 8.5 points clear of Kimi K3 on SweBench, which ties the overall score at 1 each. I expected Kimi to be closer given the price, but Claude's accuracy lead is real and consistent, and that's the trade-off you have to decide is worth 10 times the output cost. Test 3. Output speed in tokens per second. 98 tokens per second versus 62 sounds like a spec sheet number until you're sitting in an agent loop waiting for a 4,000 token code block to finish generating. That wait compounds across every step, every retry, every review cycle, and it adds up fast in a real dev workflow. I ran through independent measurements from artificial analysis, and the numbers are pretty clear. Kimi K3 outputs 98 tokens per second. GPT 5.6 Sol is at 85. Claude Opus 5 comes in slowest at 62. That's a 36-point gap between Kimi and Claude on raw throughput, measured independently rather than by the vendors themselves, which makes it more trustworthy. Kimi K3 wins speed, and that puts it ahead 2-1 over Claude Opus 5. I didn't think the speed gap would be this wide on top of the cost gap, but outputting 98 tokens per second versus Claude's 62 is a real workflow difference when you're running multi-step agent tasks all day. So Kimi K3 is cheaper and faster, but context, window, and deployment options are still on the table, and those two dimensions could flip the decision entirely if your workflow involves long code bases, image inputs, or a cloud provider your team is already locked into. Let's see what actually happens. Test 4. Context window and output limits. You're feeding a model a full monorepo, 200,000 tokens of code, and it just cuts off mid-analysis because the window is too small. That's not a hypothetical. That's a real failure mode that sends you back to chunking and stitching, which costs you hours. Context size is infrastructure, not a nice to have. I went through the vendor specs for all three. Kimi K3 has a 256K context window, the biggest of the three. Claude Opus 5 is at 200K, and GPT-5.6 Sol trails at 128K. On output length, Claude flips it, 32K max output versus just 16K for both Kimi and GPT-5.6 Sol, so Claude doubles the other two when you need long-generated responses. Kimi K3 takes context overall because the bigger input window wins more workloads than the output limit edge, and that moves the score to 3 wins for Kimi K3, 1 for Claude Opus 5. If you're generating massive single-pass outputs, Claude's 32K ceiling is genuinely useful, but for most code-based analysis jobs, 256K context is the more decisive spec. Test 5. Deployment options and input modalities. Your security team says the model has to run inside your own VPC, or your product needs to analyze a screenshot alongside code. Either of those requirements immediately disqualifies one or more of these models, and most people don't check this until they're already mid-integration, which is a painful place to find out. I went through the official docs for all three. Kimi K3 is open weight, available on Hugging Face, and runs on the Moonshot API, text input only. Claude Opus 5 covers Anthropic's API, plus Bedrock, Vertex, and Azure, and it takes text and image input. GPT 5.6 Sol runs on OpenAI's API in Azure, also text and image. So Kimi's the only one you can actually host yourself, but it can't read images. The honest caveat is that these two advantages pull in opposite directions. Open weights versus image input, so which one matters more is entirely about your use case. If you're on a regulated team that can't send data to a third-party API, Kimi's open weight option is the only viable path. If your workflow touches screenshots or diagrams, Claude or GPT 5.6 Sol are your only options. Deployment is a tie, and the final score lands at Kimi K3 3, Claude Opus 5 1, GPT 5.6, Sol 0 with 1 tied. I thought one side would clearly dominate here, but open weights and image input are genuinely different requirements that don't cancel each other out. Kimi K3 wins on cost, speed, and context window. It's 10 times cheaper on output than Claude Opus 5, outputs 98 tokens per second versus Claude's 62, and has the biggest input window at 256K tokens. It's also the only open weight option here, so you can run it on your own hardware with no data leaving your infrastructure. Claude Opus 5 wins on raw coding accuracy and output length. It scores 80.9 on SWE bench verified versus 72.4 for Kimi K3, and it's the only model here with a 32K token output limit. It also accepts image input and has the widest managed cloud reach, covering Bedrock, Vertex, and Azure out of the box. GPT 5.6 Sol doesn't lead on any single dimension in this comparison. It's a middle ground option, cheaper than Claude Opus 5, but more expensive than Kimi K3, faster than Claude but slower than Kimi, and it accepts image input like Claude. If you're already deep in the OpenAI ecosystem and need image support without paying Claude Opus 5 prices, it's a reasonable middle path. Alright, so if raw coding accuracy at 80.9 SWE bench is non-negotiable, pick Claude Opus 5. Same answer if you need image input or 32K output. For everything else, Kimi K3 wins and the margin is real. 10 times cheaper on output, 36 tokens per second faster, bigger context window. GPT 5.6 Sol is the call only if you're already on OpenAI infrastructure and need image support without the Claude price tag. One thing that'll catch you off guard with Kimi K3, that $0.60 input price is the cached rate. Moonshot's own blog lists a 3 per million cache miss rate and 15 per million on output when cache is cold. The first call on a new session always misses cache, so your real cost on cold starts as meaningfully higher than the headline number suggests. if you're trying to figure out where Kimi K3 actually fits into your local setup versus managed options. I did a full breakdown in Kimi K3 versus Allama versus LM Studio, which runs best locally. And the results are pretty interesting because local inference changes the cost math completely. That one's worth checking out next.